Hi friends, we have seen logical operators, arithmetic operators, relational operators, assignment operators, increment and decrement operator, conditional operator, and we are left with bitwise operators. We have seen already size of operator, instance of and new operator. This is a lambda operator, okay, lambda expression which they have introduced in LINQ. Okay, .NET has introduced in LINQ. We'll be getting the information of these operators as and when we need. Okay, because even I hope you remember that we have seen size of operator before seeing all these things. Like that, whenever we need, we will be learning one by one the new operators. Now we are going to learn bitwise operators. Bitwise operators. Okay, let me open the Unity and we open the data types demo. Okay, I think I have some code previously written. Let me minimize this too. Now bitwise operators, there are 4 important bitwise operators we have: bitwise AND, bitwise OR, bitwise exclusive OR, and bitwise complement. Okay, we have seen logical AND, right, which is based on true or false, all these things, whereas bitwise AND OR, these are based on bits. Okay, I'll be telling you what are those. Okay, bitwise operators, and we will be getting some information about them now. After that we'll come to bitwise shift operators. Let me minimize. Here I have a table for you. The first one is a bitwise AND table. I hope you remember logical AND, where we have seen if let me close this and open in Paint so that we can make it little bit colorful. Now this one is AND, okay, that is to bitwise AND it is, and you will be using only one symbol, that is ampersand, whereas in logical AND we use 2 ampersand, right? Here only 1 ampersand. And if you remember logical AND, if both the statements are true, then the result will be true, right? Same thing is there in the bitwise operator. Only thing is if both the left hand side and the right hand side have the 1 1, then the result will be 1. In all other cases it is 0. Whereas bitwise OR, if both the left hand side and the right hand side are 0, then the result will be 0. In all other cases it is 1. Okay, that is bitwise OR. Okay, bitwise OR. Okay, we use only one pipeline. There we have used 2 pipelines in where logical operators. Then we have one more operator that is actually called as exclusive OR. Okay, exclusive OR. Okay, if you have studied relational algebra, there they will use a symbol something like this. It looks like a plus sign surrounded by a circle. Okay, that is exclusive OR. Now what is exclusive OR? Exclusive is OR is a kind of checking an equality kind of operator. Okay, if both the left hand side and the right hand side are same, okay, you can see here both the left hand side and both are same. Okay, PQ is 1 1 and PQ is 0 0. In that situation the result will be 0. If both are different, then the result will be 1. Okay, that is exclusive OR. Now we can understand these things, all these three. Then we will move to the next operators. Okay, let us see in code. We have a code ready. Now debug .log that is Bitwise Operators. Debug.log. Let us see the bitwise operation AND. Okay, bitwise operator, as I told, 1 if you have and 1. Okay, you have a number 1, then you have a bitwise and, then 1. Okay, let us save, come back to console and check out the main camera whether we have attached the script or not. No, let us attach the script, data types demo, and let us run and check what output we get. And you can see that output is 1. It's same like logical AND, only it works with the numerics here, you can see. Okay, if you change this one to 0, then definitely you will be getting 0 over here. Why? Because we know that the bitwise AND is true if and only if both the left hand side and right hand side are 1. We got the 0. Okay, then we have debug.log bitwise OR. What it says, if both the left hand side and the right hand side are 0, then the result will be 0, otherwise in other cases it is 1. Now if I run this, I should get 0 over here. And you can see that we are getting here 0. Okay, and here also 0, because 1 0 1 and 0 is 0, and 0 or 0 is also 0. Now if I have to get here 1, any one of these should be true, right? If both of are true, then also you will get 1. If both of them are 0, then you will get 0. In all other cases it is 1, right? Now if I save and run, the last output should be 1. Clear this and let us run. And you can see that the output is 1. Okay, then we have debug.log exclusive OR, right? 1, you have a caret sign just above the number 6 on your keyboard, and here I'll write 1 and 1. As we know that exclusive OR is if both are same, then the result will be 0. Let us save, and we should get here the result should be 0, and here we have already seen the result will be 1, and here we have already seen the result will be 0. Okay, if I run this, we will be getting the output as 0. Let us see for 0 0, because if both are same, then the result will be 0 only, it should come. Let me save this and come back. And let us run. And you can see that we have got 0. Now if any one is different, okay, if maybe this one is different 1, or maybe this one is 1, okay, if both are different, then the result has to be 1 here. Save this. And let us run the code. And you can see that we got 1 at the end. That is about bitwise AND, bitwise OR, and bitwise exclusive OR. But they are not going to be only used for 1 or 0 like that. You can use with the integer numbers. Let me show an example for that. Debug.log 2 and 2. Okay, I am using now the number. You can use any number here, 10 or 20 or 30, whatever you want. Now 2 and 2, what we get? The result. Okay, how this will be interpreted? Actually, we get the result as 2 only. Let me show that here. Okay, in the MS Paint, what I do, what actually the system does means, you have written 2. You have written 2 and 2 you have given. Okay, now what it does, first it converts this 2 into bits. Bits, how we will convert a decimal number to a binary number means, you have to write down here 2 raised to the power of 0, then 2 raised to the power of 1, then 2 raised to the power of 2, then 2 raised to the power of 3. Like that you can continuously write down. And then if you want 2, okay, we know that 2 raised to the power of 0 is 1, 2 raised to the power of 1 is 2, 2 raised to the power of 2 is 4, 2 raised to the power of 3 is 8. Now I want that what is the value of a decimal number 2 in the binary means, I will write here 1, in all other places I will put 0. Now this indicates 2. Okay, why? Because we have 1 here, 1. Okay, if you want to represent 3, then you have to write here 1, here 1. 2 plus 1 will be 3. Okay, actually we will be having plus here in between if you want to get the final result. Okay, I will just show you. Then this 2 will be like this, 0, 0, 1, 0. What we get? Now it will do the bitwise ANDing. Okay, if you do bitwise ANDing, what bitwise AND says? If both are 1, then 1. In all other cases it is 0. So what is this? This is the value 2 again. Okay, let me show few examples for finding out the different values. Okay, let us take, you want to find out what is the value of or equivalent value of a decimal number 3 in binary means, you have to write 1, 1. Why? Because 1, 2. 2 plus 1 is equal to 3. That is, this is the binary equivalent. Okay, 1, 1. Let us take, I want to represent 5. How do you represent 5 in binary? First you write 1, then 2, then 4, then 8. Now I want 5. What I have to do? I will write here 1 and here 1. Then these two places I will put 0. Now what is this? 4 plus 1, which is equal to 5. Let us take, you want to represent 65. How do you represent it in binary? So you need to write down a little bit more. 1, 2, 4, 8, 16, 32, then 64. Right? 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to 3, 2 raised to the power of 4, 2 raised to the power of 5, 2 raised to the power of 6. Now if I have to represent 65, I have to write here 1, I have to write here 1, and the remaining all places I have to fill 0. Then this is the binary equivalent of 65. Okay, I hope you understood how do you convert a decimal number into a binary number. And even you can find out a binary number to the decimal. Just you have to write on the numbers, these numbers, and you just need to add this and you will get the 65. That's all. This is how the bitwise AND operator works. Takes a number, converts into the binary number first, takes another number, converts into binary, then bitwise ANDing it will do. The resultant value will be returned back as an integer again. Okay, decimal number back. Now let us see some other example. Okay, one more example for debug.log. Let us take, I want to find out the bitwise ANDing of 2, bitwise ORing of 2 and 5. How do we do that? Okay, what result we get? Let us see. First I will do here. So 2 bitwise ORing with 5. So 2, how do we write? 0, 0, 1, 0. This is 2. Right, 1, 2. Now if I have to represent 5, how do I represent? 1, 0, 1, 0. And here we have to do bitwise ORing. Right. 1 and 4. 4 plus 1 is 5. Remember that one. Okay, here I will write if you want 1, 2, 4 and 8. 4 plus 1 is 5. This is how you represent. This is bitwise OR. Okay, OR. Now what OR says, if both are 0 then 0. In all other cases it is 1. Now what is this? This is actually equal to 4 plus 2, 6 plus 1, 7. The answer will be 7. Let us see now whether we are getting the value 7 or not. Let me save this and minimize and come back to this, and we clear this and we run the code. And you can see that we got here 2 and we got here 7. That is how the bitwise operator work with the integers, and these will work only with the integers. They won't work with any floating point or decimal numbers, the bitwise operators. Remember that one. Okay, now I hope you understood clearly bitwise AND means what, bitwise OR means what. The same thing, the bitwise exclusive OR, you can try and look out. Okay, it is very, as I told, if here both are same, only few things you need to remember. Anyhow, I have given you here the truth table of all the operators. Just remember, if both are same then 0 in the exclusive OR. We have seen 3 operators. We have to see other operators. Let me stop this and clear this, and we will be having the complement operator. Okay, now let us see bitwise OR operator, complement operator. Okay, debug.log complement of let us take, you want to find out the complement of 2, the number. Now how do you find out? I just need to tell you the simple technique you need to remember is, if it is a positive number, okay, if the number is positive, what you need to do then, add 1 to that number and change sign. That's it. That is what you need to do. Okay, so what you will get the result, if you add 1 to it, you will get 3. If you change the sign means positive or negative. It is positive, so you should get the result as -3. Let me save and check out the result for this. If I run this code, you will see that it is -3. Okay, whereas if it is negative, okay, let me copy this one and paste. If it is, let us take -2, you want to find out the complement of negative value, negative number, then what you need to do is, instead of adding, if it is negative, then you need to subtract 1 and change the sign. Okay, let us save. That means we should get the value for this is 1, right? Let us see. Right, we got the result here 1. Right, that is how you are going to do the bitwise complement here. Okay, after that you have bitwise left shift and right shift. Okay, log. Now if you have to do left shift or a right shift, okay, what we need to do, bitwise left shift or a right shift. Okay, let us take, you have a number which is gonna be 1, and if you are left shift by 4 digits, okay, 4 locations, then what result you will get? Okay, let me explain this one so that you will get an idea. Now I just select and remove everything from here. Okay, I think now we don't need these tables. I'll explain here only. Now you have 1. Now if you, on this left hand side, okay, if you have a block like this, let us take, okay, 1, 2, 3, 4 and 5. Okay, here you will be having 1, 2, 4, 8, 16. Okay. Now if you shift this 1 towards left hand side by 4 places, okay, that is the meaning of this line. Take 1, shift it left hand side 4 places in the memory, okay, bits. Now I move with this 1, this place to this place. So 1 shift, 2 shift, 3 shift, 4 shift. 1 will come here, and all the remaining blocks that is there here are going to filled by 0. Okay, now what is the value of this? This is 16. Now you are going to get the result as 16. Okay, let me show that. Let us save this. What should I get here? I should get the value 16. Let's save this and clear this one. Okay, run the code. You can see that it is showing 16. Okay, same thing you can do for a right shift also. Okay, let us take debug.log. You have a 16 right shift by 4 bits. Then what should you get? 1, correct or not? Let me show that one back. Now you already have a 16 value, right? Like, let me put a box again. 1, 2, 3, 4, 5. Okay, here you have already 1. Okay, remaining places are actually filled by 0. Okay, now you are going to shift it by 4 bits. 1, 2, 3, 4. You got 1 here, and all other bits will be filled by 0. Okay, now what is this? This is 1. Now we have to see the result. Let us save, and we should get the output as 1 at the end. Can you see this? We are getting 1. That is bitwise left shift and right shift. But I will tell you the trick. What you need to do easily to calculate any number means, what you need is, you take the number, that is whatever is there over here. Okay, take that number. Okay, if it is a left shift, then you multiply by power of 2 comma this number. Okay, whatever this number. Okay, what you do, take 1, that is this number. If it is a left shift, multiply by 2 raised to the power of this number. Then you will get the result. Let me show that math. As I told here, 1 raised to the power of 2. Okay, 2 power 1. Now as I told, you have 1 here. If it is left shift, you have to multiply. Then 2 raised to the power of this number. So 2 raised to the power of 4. What is 2 raised to the power of 4? 16. 16 multiplied by 1, the result will be 16. This is a trick for this. Now same thing if you are doing for this one, it will be reverse. What you need to do is, take the number. Okay, take that number, whatever number is here. Instead of multiplying, you divide it by power 2 comma 4. 2 raised to the power of 4. Let me show that one for clarity. We have a 16, that is a number, and divided by 2 raised to the power of 4. So 2 raised to the power of 4. What is 2 raised to the power of 4? 16. So 16, 16. Gone. We got the result 1. That is the output we are getting here. Okay. End of the result of bitwise operators will be an integer number. That is the most important for us to remember. Okay. Bitwise operators are used for masking, and bitwise operators are used for color change things. Okay. There are many places we use bitwise operators in games, as well as it is mainly used in embedded machines when you are working with the hardware devices. But even though these are useful in games also. Okay, sometimes bit masking is used, and sometimes we will be using this left shift and right shift operators for working with colors and all. Okay, I'll be showing you some examples. How do you use the bitwise operators to work with colors and bit masking? Okay, that is all about the operators that we need to know. Okay, I hope you understood very clearly whatever I have explained. Please go through all these things once again. Make these stuffs worry in your mind very well. And we have covered now all the operators. That is the end of the operators chapter. But a few operators we have, like instance of, new, lambda. There are few more operators that we will be seeing as and when they come. That's it. Anything else I would like to say? Okay guys, so we have seen many concepts till now. We will be seeing, now we know a lot of things, like we know operators, we know data types, we know variables, we know how to create constants, we know how to create script, how to execute, how to debug, right? We will be seeing a lot of examples using all the concepts that we have learned till now. Okay, and we will be learning everything in depth, step by step, and each and every construct, how it is used in games or any applications, we will be seeing. Okay, please go through the concepts, and in the next tutorial maybe I will be making a summary of what and all we have learned from the beginning to till now, and few points which are most important to remember. Okay, so see you in the next tutorial. Thank you guys, thank you very much.